During the development process of a machine, there are many risks that can jeopardize its introduction into production on schedule. So why wait until the final assembly to begin testing the various parts of the machine? Virtual commissioning from Siemens allows testing to be performed in the design and planning phases of a machine. What-if scenarios can be tested ahead of time, minimizing engineering errors and reducing costs. Any errors found in the virtual world can be resolved quickly and efficiently without extensive repair costs. Six Sigma tells us that the earlier an error is found, the less it's going to cost us to resolve, because the further that propagates through our design process, the costs of resolving it increase by a factor of 10. So that's why virtual commissioning has so much potential for machine builders, plant builders, and the manufacturing enterprise in general. Commissioning a new production machine is a crucial stage in a project, as it demonstrates that the three elements of mechanical, electrical systems, and automation behave as planned. Unplanned behaviour quickly leads to delays and high costs. Using virtual commissioning tools and digital twins helps reduce this risk. It starts with a CAD model. The first element is our mechanical model, where CAD data is enriched with physical and kinematic information, allowing us to simulate motion, gravity, and collisions in our machine. Different design alternatives can be tested and simulated and validate our automation code. The next element for emulation is our electrical systems, where we want to simulate our sensors, our actuators, our drives, temperatures, pressures. We can even link out to third-party applications or introduce hardware into the loop as well. The third element is automation, where a virtual controller allows us to test all parts of our standard safety and motion application code. An open API allows us to perform data exchange with third-party applications, allowing for co-simulation. And the virtual time scaling even allows us to speed up or slow down our processes for extensive debugging. The longer it takes to commission the actual machine, the longer it's not in production and earning revenue. Performing commissioning tasks ahead of time on the digital twin can reduce the actual commissioning time by up to 70%. The digital twin allows machine builders at a very early stage in development to try out different iterations and optimize machine design. This can be taken advantage of very quickly with software-in-the-loop capabilities, where we can simulate the controller, operator interface, machine and electrical systems all in a virtual and synchronized environment. Moving on from software in the loop, we can also introduce hardware into the system, allowing us to test things like communications to other systems or validate our actual operator interface panels. This is known as hardware in the loop. Taking the information from our virtual commission tests results in our actual machine being produced with minimal prototyping and fully optimized, and the automation code is validated and ready to operate. As you've now seen, the ability to validate code with full visibility of how the machine will behave and respond has many advantages. Virtual commissioning gives you that sandbox environment which allows you to try anything with minimal risk and no need for prototyping. And of course, malfunctions and errors aren't going to cause damage to the real machine, which could result in extensive repair costs or delay on delivery. The use of a digital twin doesn't stop at the end of commissioning. It provides high-value information for additional services, such as operator training, line integration, future upgrades, modifications, and repurposing. As an example of operator training, they're able to familiarize themselves offline in a safe, risk-free environment before operating the machine in the real world. This reduces orientation time on the real machine and increases service quality. Siemens Virtual Commissioning offers many advantages over the traditional machine development process. By adopting our technology, you can be confident that the next machine you build will be a production one and not a prototype.